going to consider parabolas from a conics point of view. Just as a review, in the quadratic form, f of x equals ax squared plus bx plus c, and in the vertex form, f of x equals a times x minus h, all squared minus k. In both cases, if a, the leading coefficient, is positive, the parabola opens up. And if a is negative, the leading coefficient, the parabola opens down. Certain angles of the intersection of the plane give us the parabola. This means the parabola is one of the conic sections. Let's begin with this diagram from OpenStax.org of key features of an upward-facing parabola. We can see the vertex, of course, is the minimum or the lowest point, and the axis of symmetry is the vertical line through the vertex. Directly underneath the vertex is a line that is called the directrix. The distance from this line to the vertex, if we go up that distance, we get to this point here called the focus. This line along the bottom here is the directrix, and this red point F here is the focus. This distance from the directrix to the vertex of the parabola is 2.8, and then the distance from the vertex of the parabola to the focus is 2.8. Now, as I move this point, I trace out my parabola. And notice what happens as I move this point. This distance increases, but the distance from M to P and the distance from P to F is always equal. As I do this, I trace out my parabola. And remember, these distances, while they do increase or decrease if I'm going down, they're always equal. They're always the same distance. So in this diagram from OpenStax.org, College Algebra, the directrix has the equation y equals minus p. Focus, the point right here, is 0p. The vertex is 0, 0. And the parabola, any arbitrary point on the parabola, is x, y. So this point directly underneath is x minus p. So the distance from the focus to the parabola, d from the focus to the parabola, is x minus 0 squared plus y minus p squared, and the distance from the parabola to the point x minus p, that's x minus x squared, and y minus p, so that'll be y plus p, all squared. So we know these are the same distance, so we have x squared plus y minus p all squared under the square root, and that's equal to the square root of y plus p all squared. So that's actually x squared plus y minus p all squared under the square root equals just y plus p. So if I square both sides, I get x squared plus y squared minus 2yp plus p squared equals y squared plus 2yp plus p squared. So I can subtract p squared from both sides. I can subtract y squared from both sides. That gives me x squared minus 2yp equals 2yp. So x squared equals 4yp. So if we consider the standard form of the parabola with the vertex at the origin, if the axis of symmetry is the x-axis, then the parabola opens right or opens left. The equation is y squared equals 4px. Focus, the point P0, directrix x equals minus p. If the axis of symmetry is the y-axis, the parabola opens up or down. The equation is x squared equals 4py, focus 0p, and the directrix is y equals minus p. Notice if the directrix is above the parabola, it's going to open down. If the directrix is below, the parabola opens up. If the directrix is to the left of the parabola, it opens to the right. If the directrix is to the right of the parabola, it opens left. In the example, graph the parabola y squared equals 12x, identify the focus and the directrix. So I know this has the form y squared equals 4px. The leading coefficient is positives and the squared term is on the y, so it's going to open to the right. And I see that 4px equals 12x. So that means 4p equals 12. P is equal to 3. Since it opens to the right, the focus will be at the point 3, 0, And the directrix will have the equation P equals -3. So here's the graph of the parabola, the directrix to the left since it opens to the right, and here's the focus, the point 3, 0. To determine how wide to graph the parabola, we determine the length of a line segment that passes through the focus perpendicular to the axis of symmetry with the endpoints on the parabola. This line segment is called the latus rectum. Latus is Latin for the word side and rectum for the word straight. So the line in question is here. So I'm going to go from this point to this point. This line is the latus rectum, and the coordinates here are P, absolute value of 2P, and P, negative absolute value of 2P. So in the case of y squared equals 12x, here's our line segment, the latus rectum. The points are -6, 3 and +6, 3. The length of the latus rectum is called the focal diameter and is 4 times the absolute value of P units. Given 2x squared equals -8y, part A is identify the vertex, the focus and the focal diameter, B is the endpoints and graph, C is to write the equation of the directrix and the axis of symmetry. If I was going to solve this for y, which I shouldn't in this case, but I would get y equals -1/4 x squared. So I know this is a parabola that opens down, but I want to write this in terms of its conic equations. So this becomes x squared equals -4y. Since x squared equals 4py, I know that 4py must equal -4y. So p is equal to -1. So the vertex goes through the origin. It opens down, I know that. The focus will be 0, -1. The focal diameter, 4 times the absolute value of P, is 4 times the absolute value of 1. So the focal diameter is 4. So I know the x-coordinate of the endpoints that are on the parabola of the latus rectum will be ±2 times the absolute value of P, so that's just going to be ±2. So I'm going to get -2 -1, because it has to go through the same line as the focus, which is y equals -1, and +2, -1. The equation of the directrix will be y equals 1, y equals -p. The axis of symmetry is x equals 0. Focus is 0, -1. The directrix is y equals 1. The 2 points on the latus rectum are -2, -1, and +2, -1. So that has a line segment that is 4 across. That enables me to graph my parabola. The axis of symmetry is x equals 0, the y-axis. Now we have the standard form of parabolas with the vertex of hk and not at the origin. The axis of symmetry, if it's y equals k, and the equation is y minus k squared equals 4px minus h, then the focus is h plus pk, the directrix is x equals h minus p, etc. If the axis of symmetry is x equals h, then we have x minus h squared equals 4p times y minus k, and the focus is h, k plus p, and the directrix is y equals k minus p. In this example, we're given 2x squared minus 8x plus 4y plus 24 equals 0. Our first task is to write the equation in standard form. So I'm going to put all the x terms on one side, 2, and I'm going to do x squared minus 4x, put all the y terms on the other side, so that's minus 4y minus 24. Now I need to complete the square, so I have -4 divided by 2, that's the coefficient of the x term, all squared, that's -2 squared, or 4. So I'm going to add 4 and also subtract 4. So this will give me 2 times x squared minus 4x plus 4, there's a perfect square, minus 4 times 2 equals minus 4y minus 24. So this is 2x minus 2 all squared minus 8 equals -4y minus 24. I'm going to add 8 to both sides. This is -4y minus 16. Then I'm going to divide both sides by 2. So I have x minus 2 squared equals negative 2, y plus 4. So the axis of symmetry here will be x equals 2, and this will open down. The vertex is at the point 2, negative 4. The focus will be at the point 2, and then minus 4 plus p. So I have to find what p is. P, well, 4p equals negative 2. So p is equal to negative 1/2. So the focus is 2, and negative 4, add negative 1/2, and that point is 2, negative 9/2. For the focal diameter, I have 4 times the absolute value of p, so that equals 2. So the focal diameter is 2. To graph the parabola, I'm going to find the 2 points that are on the lattice rectum. So I have h plus or minus 2p and k plus p. So these 2 points will be 2 plus or minus 1 and negative 4 plus negative 1/2. So these 2 points will be 1 negative 9/2 and 3 negative 9/2. That has a length of 2. The vertex is at the point 2, negative 4. The focus is 2 minus 9/2. The directrix is y equals minus 7/2. The two ends of the lattice rectum are 1 minus 9/2 and 3 minus 9/2. And here is my parabola.